All right, this is the last part of our 4.4 notes for pre-calc. The first chart here just gives you kind of a summary. They're talking about both sine and cosine graphs. We've mentioned that sinusoids refer to both of those because a cosine is just a phase shift of a sine curve. They have the following characteristics. Amplitude is A, period is 2 pi divided by the absolute value of B. Frequency, we haven't talked about that in a couple days. Frequency was the reciprocal of period. Okay? It says comparing graphs where we have the A and B in there. This caused our left, right, and up, down shifting. Okay? So we had a phase shift of H, we had a vertical shift of K. The last two examples that we're going to look at today deal with giving you some criteria and asking you to come up with an equation for it. Okay? And it generally says, give me a sinusoid equation. So it's not going to tell you necessarily if you should be using a sine or a cosine. We base it on what they're telling us. So if I were graphing a sine curve, sine starts where? Just a basic sine curve. Sine starts at 0. So if they're giving me a starting value at my 0 mark, I'm going to think in terms of sine graphs. If they're giving me something where I'm starting at a high or a low point, I'm going to think of cosine graphs because they start off of my 0 line. Does that make sense? Either a cosine with a positive a value would start high, or a cosine with a negative a value would start low. So I can kind of pick the type of sine or cosine graph that I want to use based on the information they're giving me. So our first one says to construct a sinusoid that rises from a minimum value of y being 5 when x is 0. Looking at your graph here, that's this point. When x is 0, we had a low point of 5. Okay? Then it goes to having a maximum value of 25 when x is 32. So if they hadn't given you the picture, the first thing I would do is sketch that. Okay, I'm starting at a value of 5. At 32 increments from 0, I'm up at a 25 as my maximum. Now, we can look at this and say it could be a sine or a cosine curve. It could be a sine curve that's been shifted. In other words, we could think of starting here, right? And using that as a sine curve, but we've had to do a phase shift. Or we can think of it as a cosine curve that's had what done to it? It's been flipped. It's been reflected over the x-axis. Yes? Or reflected over our new line, our new 0 line. So what's easier? It's probably just to use the cosine one. Okay? It's easy to make it flip, harder to figure out what that phase shift needs to be. Okay? So they tell me that my graph goes from a 5 as my low point to a high of 25. That's the range of my graph. Okay? I'm going to pause the video and have you guys discuss in your groups. If we know that that 5 is my low and 25 is my high, is there a way to figure out where that new 0 line should be, that new horizontal line? And is there a way to figure out what the amplitude should be? Okay? So go ahead and discuss that. All right, so what did you find first? Did you find your 0 line first, or did you find your amplitude? 0 line? Okay, how did you think through it? You averaged the two numbers? Okay, anybody else? Do you know what I mean when I say the 0 line, where that horizontal shift happened? Okay, so horizontal shift, that new 0 line is going to be halfway in between my high and low points. Where would that be? At 15. So we have a new 0 line here. Yes? Okay. So if we're at 15, in terms of my A, B, H, and K in my equation, what would that be? That's my K value, right? I've shifted it up to 15 as my new 0. So I've identified that K has to be 15. Okay. What else? If we know K is 15, can we figure out the amplitude? How do we know it's 10? Okay, so from 15 we could go up 10 to 25 or down 10 to 5. Okay, so we're saying the amplitude is 10. What else do we know? Have we done any kind of phase shift? If we're thinking of it in terms of cosine, we said we didn't need a phase shift, right? All right. So our h value would be 0 if we have no phase shift. But we said if we're going to use a cosine, we had to do what to it? We had to reflect it, right? So there's no phase shift, but we do need a reflection. So what do we have to do to cause that to reflect? Put a negative in with a, right? So my a value would be now a negative 10. My amplitude technically is still 10, right? Amplitude is just an absolute value of that distance. But our a value is going to be negative 10. What's the only other letter we haven't figured out? We haven't found b. So let's look at our graph. We started out here at time 0, all right, at x value being 0, starting at a level of 5. It told us that at 32 we're at a high point. My whole cosine curve has to go all the way to here, right? That's one period. Is this 32 the middle point? So what is this green mark over here going to be? 64. So I get one full cycle in a span of 64. We good with that? All right. So that tells me that the period equals 64. And if I know what the period is, can I work back and figure out what my b term had to be? Yes. What was the equation we had for that? Good. 2 pi divided by b gives me the period of 64. Can I divide the 64 over and multiply the b to the other side? So it really becomes 2 pi divided by 64 equaling b. And 2 divided by 64 we could reduce to pi over 32 is my b value. And now I know all the pieces I need for my equation. All right, so let's write it. What did we say our a value was? Negative 10. We said we're going to use a cosine curve. What is my b value? Good. Pi over 32 times, and normally we'd put it in parentheses, right? X minus h. But what's h? 0, right? We didn't have a phase shift, so we can just put an x in here. And then we had a vertical shift up 15. Does that make sense? Yes, no? Okay. All right. Now, I had you discussing in your groups how to figure out the a value and where that new 0 line should be, our vertical shift. There is a formula we can use to figure that out. If you like doing it visually or drawing it out on paper, that's fine too. It says, to construct a sinusoidal model using time, determine the maximum value m, capital M, and minimum value lowercase m. The amplitude of your graph will be capital M, so maximum minus minimum divided by 2. Let's think if that worked. In our last example, our range went from 5 to 25. So they're saying take high minus low, 25 minus 5 divided by 2, which gives us 10. Was that our amplitude in the last question? Okay. Then it says to find the vertical shift, we can add the two values together, the high and low. So 25 plus 5 divided by 2, and we get 15. Was that our vertical shift? We went up 15? Okay, so if you want to use the formulas, you can. If you want to analyze it based on, I know my high and low, I'm going to split it in the middle to get my horizontal line, my phase shift line, and then I can figure out the amplitude from there. Determine the period. the time interval of a single cycle, and you can find your horizontal or your B value, your horizontal compression, by taking 2 pi divided by P. In our last example, P was 64. We took 2 pi divided by 64 to get our B term. Yes? All right. The third thing in here kind of talks about what I mentioned earlier. How do you determine, should I use a sine curve? Should I use a cosine curve? What are they asking me to figure out? So of these options, if you start out with a cosine and a positive A value, where are you starting your graph? If it's a cosine with a positive A value, you're starting at a high point. Cosine graphs, we're starting at a high point. Yes? Okay. What if our cosine graph was negative? Where do we start if cosine's negative? I mean, if our A value is negative. We start at a low point. So if they are giving me a description and they're telling me at this time, here I'm at a high point, I'm going to use the cosine that has a positive A. If that starting time I have a negative value, I'm going to start with a negative A value. Sines start where? Okay, so a normal sine curve starts at 0. Now keep in mind we can raise and lower that, right? We can have a vertical shift. So if you think of sine as being your new 0, starting on your new 0 line, okay, then you just have to decide. From there, am I going up, in which case we want a positive A value, or am I going down, in which case I need a negative A value? Okay? All right, our last example. It says, one particular July 4th in Galveston, Texas, high tide occurred at 9:36 a.m. At that time, the water at the end of the 61st Street Pier was 2.7 meters deep. Low tide occurred at 3:48 p.m., at which time the water was only 2.1 meters deep. Assume that the depth of the water is a sinusoidal function of time with a period of half a lunar day, which is 12 hours, 24 minutes. Okay, now the first thing I want you to do, when we're talking about time, like 9 hours, 36 minutes, it's going to be a lot easier to do our calculations if that's a decimal number instead of hours and minutes. Okay? It's easier to add and subtract with decimals than hours and minutes notation. So how would we take this 36 minutes and convert it to a portion of an hour? Okay, so if you think of dividing both of those by 6, what do you get? This becomes 6, this becomes 10. I know it can be reduced further, but in terms of decimals, our first decimal point is considered a tenth, right? So this would be 6/10. So 9 hours, 36 minutes is really 9.6 hours. Does that make sense? All right, let's look at our other time. 3:48 p.m. What would 48 minutes be in terms of a decimal? 48, if we change this 36 to a 48, it becomes an 8. If we divide by 6s, 8/10. And what about 3? How do we determine 3 p.m. versus 3 a.m.? Can we think in terms of military time? Do you know what I mean by that? So anything after noon, like 1 p.m. would be 13, right? So 3 p.m. would be 15.8 hours. Okay. 12 hours and 24 minutes. What decimal would be equivalent to the 24 minutes? You're just dividing by 6, right? So 12.4. All right. While we're at it, what would our increments be if our period was 12.4 hours? 3.1? Cut it into 4 pieces. 12.4 divided by 4 is 3.1. All right. Now, it's asking us to come up with a model, and then we're going to use that model to answer some other questions. So first of all, we need to figure out our A, B, H, and K. Let's start out figuring out A and K like we did on the last question. What is low in this case? What's my low tide? 2.1 meters. My high tide is 2.7 meters. So I am ranging between 2.1 and 2.7. Yes? Okay. So what do I do to figure out K? That's why I'm afraid of just saying memorize the formulas, because now you're going, do I add, do I subtract? Which one do I do? K is going to be where in reference to a 2.1 and a 2.7? In the middle, right? How do you find the middle? Average them, right? Add them and divide by 2. Okay, 2.1 plus 2.7 divided by 2. Okay. So that is my K value. That's my new 0 line. What would the amplitude be? Y.3. Right. From 2.4 up to 2.7 is 0.3. Down to 2.1 is also 0.3, right? Yes? Okay. You can do the formula if you want, but again, I just want to make sure you're visualizing it, that it makes sense. Okay. Now we need to decide if we should use a sine or a cosine. They are telling me the first set of data that I am given, at 9.6 hours, I'm at high tide. So what makes sense? To use a cosine. Do I need to reflect it if I'm starting at a high point? No. All right, so we are going to use cosine because we are starting at a high point. We did not need a reflection. But we needed something else because we're not starting at 0 time, right, at midnight. We're starting at 9.6 hours. So we've shifted from 0 over to 9.6 hours. That's a phase shift. So we don't need a reflection, but this time we need a phase shift of 9.6 to the right. Okay? You with me? All right. What else do we need? We found our H value, right? 9.6 would be our H value. We know our K value. We know our amplitude. We need B. What did they tell us the period was? 12.4 hours. So if we know the period is 12.4, B is 2 pi divided by the period, right? Or period is 2 pi divided by B if you want to start with that, rearrange it. So B is going to be 2 pi divided by 12.4. Can we reduce the 2 and the 12.4 to 1 and 6.2? So our B term is going to be pi divided by 6.2. Okay, so we have all the pieces. We can write our model out. Instead of using x's and y's, we're going to use time in place of x, okay, because we are looking at a time, an hour change in our horizontal direction. And then our y value is going to represent the depth of the tide, okay, the water level. So I'm going to say d of t, so the depth at time t equals, my a value was 0.3. We said we are going to use a cosine graph. My b value was pi over 6.2. I have a phase shift, so in parentheses, what am I going to write? Great, x minus 9.6. We went right 9.6. And then we had to do a vertical shift up 2.4. Okay? Wasn't that cool? Yes, thank you. X should be t. Good catch, Max. Good catch, T-table, all three of you. All right. So now we have a few questions to ask. The first one says, at what time on the 4th of July did the first low tide occur? Second one says, what is the approximate depth of the water at 6 a.m. and at 3 p.m.? And the third question, what was the first time on July 4th when the water level was 2.4 meters deep? Okay, so we have a lot of questions to ask and to answer. We have a formula, we have a new function, right? Came up with this wonderful model here that we can use to help us answer these questions. It says, at what time on the 4th of July did the first low tide occur? Well, what was low tide? What depth? 2.1 meters. Could we put 2.1 meters in here for depth and solve for t? Okay, we're going to do that. So 2.1 equals 0.3 cosine pi over 6.2 times t minus 9.6 plus 2.4. How do we solve something like that? Subtracting the 2.4 is a wonderful start. What does that get us? Okay, negative 0.3 equals 0.3 cosine pi over 6.2 times t minus 9.6. What do you think we should do next? What do we get if we divide out the 0.3? What about it? It's 6.2, pi over 6.2. Okay, so if we divide by 0.3, we get negative 1, equaling the cosine of pi over 6.2 times t minus 9.6. Okay, now here you have to take a step back and think, because we got this whole big mess in parentheses over here on the right, and it's saying if we take the cosine of all that mess, we should get negative 1. Where on our unit circle, for what angle would we get a cosine of negative 1? At 180 degrees, which in radians would be pi, right? If we go over to pi, we have a cosine of negative 1. Can you visualize that on the unit circle? Okay, so what that's telling me is that this whole big mess on the right-hand side has to really be pi. If I were taking the cosine of pi, I would get negative 1. So I'm going to set those equal. I'm going to say pi has to equal pi over 6.2 times t minus 9.6. And I can use that to solve for t. Okay? That's how you undo a cosine or a sine. You have to think in terms of your unit circle. So what would we do to get rid of the pi over 6.2? Multiply it to the other side, right? Multiply by the reciprocal. What's going to happen to the pi's? They cancel out. We end up with 6.2 equaling t minus 9.6. Okay. Can we then add the 9.6 over? And what do we get? Perfect. 15.8 equals t. Now, 15.8, that sounds familiar. Did we have a low tide at 15.8 hours? Yes, that was the 348 they gave us, right? All that work to get something we already knew. However, what did the question really ask us? the first low tide, right? The first low tide. This is a cosine graph that just keeps repeating over and over again, right? High tide, middle, low tide, middle, high tide. So we're going to hit low tide several times during the day. Can we go back one period and still be in the same day? How long is a period? So if we're at 15.8 hours, we could go back 12.4 hours and we'd be at the same low tide. Okay, so let's take 15.8, get rid of one period, 12.4. Where are we at? 3.4. Okay, what's 3.4 in terms of time? The 0.4 would be how many minutes? 24 minutes. So this is 3:24 a.m. Okay. All right. I think let's go and do part C next, and then we'll go back to part B. When was the first time on July 4th when the water was 2.4 meters deep? Well, very similar to what we just did, right? But we're going to use 2.4 instead of 2.1. All right. 2.4 equals 0.3 cosine pi over 6.2 times t minus 9.6 plus 2.4. What did we do first? Subtract the 2.4, which gives us 0. Then what did we do? Divide out our 0.3. What's 0 divided by 0.3? Still 0. So we're really saying that 0 equals the cosine of pi over 6.2 times t minus 9.6. Where on the unit circle is the cosine equal to 0? At 90 degrees, right? Pi over 2. So all the mess on the right-hand side has to be equivalent to pi over 2. Can we multiply by the reciprocal of pi over 6.2? What's going to happen here? The pi's will cancel. We're going to have 6.2 divided by 2, which gives us 3.1. Okay, then what? Add 9.6 over, we get 12.7. That is the point, or that is one of the points during the day when we hit 2.4 meters. Is there an earlier time? Can we go back 12.4 and still be in the same day? Yes? Okay. So at 0.3 hours would be the very first time that we hit the 2.4 meter mark. What is 0.3? 18 minutes. So we're talking 12:18 a.m. 18 minutes into our day, we're at our new 0 of 2.4, and then we start going up and down from there. All right, let's go back and do question B. It says, what was the approximate depth of the water at 6 a.m. and at 3 p.m.? Have we been given any of this? Like 6 a.m. time? We don't know a depth at 6 a.m. yet, right? Could we put 6 in for time? We've been solving for t knowing what the depth is supposed to be. Now this is the reverse. They're giving me a t value and saying figure out the depth value. Okay, so we can put 6 a.m. in as t being 6. But what are we going to do for 3 p.m.? We need to put that in as a 15, right? Military time? Okay, now we're going to type this in on our calculator and then be able to just recall it and do the second one real quickly. Okay, so let's set up our formula. We said the depth at 6 a.m. is 0.3 times the cosine of pi over 6.2 times our t-value, 6 minus 9.6, plus the vertical shift of 2.4. What mode, I hear all of you grabbing your calculators, what mode do you need to be in to type this in your calculator? Why do you need to be in radian mode? Because they're giving you pi over something, right? They're giving you radian measure. So make sure your calculator is in radian mode, and you should be able to type it in just like we have it here, all in one big long string, and hit enter. I was going to say it's a little bit off. Something's off there. Try it again. Or just this? Well, you should be getting answers for both, but it should be bigger than that. Do you have it in radian mode? Okay. What are we getting? Should be 2 point something, right? Because we're bouncing between 2.1 and 2.7. So at any time during the day, we need to be somewhere in between those numbers. What are we getting? For the first one, for 6, we got 2.32. Good. 2.32 meters. Now, I said you could recall that, right? You don't have to retype the whole thing. Recall your entry, second enter, and change your 6 to a 15. There's one issue. You have one space here with the 6, and you're trying to rewrite it with a 1 and a 5. Change the 6 to a 1, and then how do you insert that 5? Second, your delete key, right, is an insert. So you can do second delete, put a 5 in there, and then hit enter, and it'll calculate it for you. What do we get for D of 15? 2.12 meters. Okay, questions? All right, I will come around. If you weren't getting those answers on your calculator, we'll try to troubleshoot that in just a second. I want you to think visually of this graph. This is time, this is depth, right? We said at 9.6 hours, we were up here at 2.7, yes? And we had a line at 2.4 for our new zero, and our low point was at 2.1. Okay, so if we think about it, we said increments for time, for the period, we cut it into 4 increments, and we got how long? 3.1. So every 3.1 hours would be another tick mark. So if we add 3.1 to this, we get 12.7. And that was when we hit the 0 line, right? Well, we just found that right here. At 12.7, we were at 2.4 meters for depth. If we add another 3.1 to this, we get 15.8. We were at a low point of that 2.1 meters, right? They gave us all of this information. So when they asked us to figure out when is the first time we hit a low tide or we hit a 2.4 mark, could we have just kept going back in 3.1 increments and continued our graph to the left and figured out what those times would be? It's not as much fun as what we did, but it's another way to check your work. Okay, so yesterday we gave you a fairly long assignment. It had some word problems on it like this. Okay, I want you to take some time today to go back and look at those and make sure you truly understand them. And then I don't have a new book assignment for you. your task is to write me a little paragraph, or a nice long paragraph. Pretend you are describing how to graph sine and cosine graphs to someone who has been absent for this whole week of figuring all this stuff out. What would you need to tell them? All right, your paragraph needs to talk about A, B, H, K, what they all do, where a sine curve starts normally, where a cosine curve starts normally. How do you figure out if I have a phase shift? Where's my new starting and ending points? All of that. Okay?